Today we're going to hear from one of Flat Earth's finest minds, a guy that said this.
It will charge. It's a generator. The alternator is a generator. It's called an alternator because it alternates the spark to different spark plugs, but also because it alternates as in alternative current.
We'll get back to you on that, Antonio. Yep, this is Antonio Subirats, and he's going to tell us how Eratosthenes got it all wrong.
The fabulous story of Eratosthenes. Eratosthenes saw a shadow 7.2 degrees, that's 1/50th of a 360-degree circle. The distance between the shadow at 7.2 degrees and the source at 0 degrees, giving him a baseline. The distance between the two was, well, here. 525 miles by plane, but they didn't have planes, so it was by foot. And this blue line is the road.
Yeah, they also didn't have modern roads, Antonio. And they didn't have MapQuest or whatever it is you were using. Actually, let's try to get that straight. The pharaonic bookkeepers gave a distance between Aswan and Alexandria of 5,000 stadia. Most people think that was about 579 feet. So what he really measured is 27,400 miles. But you're going to come to that in a minute, I'm sure.
657. So let's multiply 657 by 50. 657. We won't throw in the 0.26, okay? We'll try and be fair to them. Times 50 equals 32,000 miles. 32,850 miles. That's what he thought the circumference of the Earth was, right? That's how the story goes.
Well, no, that's not how the story goes, but continue.
However, this is Hipparchus of Rhodes. Notice how Eratosthenes died in 1994 BC. The years BC go backwards. Okay, so they progress backwards towards 0 and then they go on forwards. So the next year will have been
194, not 1994.
193. The year after that, 192. And then 190.
Wait a minute. What'd you do with 191? You put it back, Antonio. You can't just put it back.
At 190 is when this fellow was born. Hipparchus of Rhodes. Hipparchus of Rhodes was the mathematician who received from the Babylonians the 360 protractor.
Well, I looked up Hipparchus of Rhodes, and I couldn't find in here anywhere where it said he got a protractor from the Babylonians. I don't know what happened, but that's not what this says. It basically says that he was the first Greek. Here we go. He was the first Greek known to divide the circle into 360 degrees. But, hey, okay, if you say he somehow got a protractor from a basically extinct civilization, all right.
That's right. This fellow was born 4 years after this fellow died. But wait a minute, if this fellow received the 360-degree protractor, what the heck did this fellow use? He used the scapher. The scapher divides the circle into 60. Now, if you divide 5.7 degrees...
Wait a minute, where did 5.7 degrees come from?
Into a circle of 60. If you see how many segments 7.5 degrees will be.
Now, wait a minute, now you're at 7.5 degrees. Earlier you were at 7.2 degrees. Which one are we using?
It would be just over one segment of a...
Actually, if you use 7.2, it would be in a 60 segment circle. It would be 1.2 segments. That's still 1/50th of the total circumference.
A scapher. That's 1 of 60. So let's do what we just did and multiply this distance by 60. Okay, so 657 multiplied instead of 50 like the protractor says, because 7.2 degrees is 1/50th of a 360 circle. 7.2 degrees breaks down to being just over one segment of a
1.2 segments, Antonio.
60 segment circle. So times 60 equals 39,420 miles.
Oh, good grief, Antonio. He probably didn't do any of this. I just duplicated that experiment last week, and I'm going to play a little video clip for you right now to show you how this is done, not using a protractor, not using any trigonometry, just a very simple little geometric trick. So have a watch at this. So there have been some questions about how a guy like Eratosthenes could have made these calculations at a time before trigonometry had been invented. So it turns out that we can do this very, very simply. We can do it geometrically. What I've done is I've taken a piece of paper and I have constructed a replica of the measured sun angle from the equinox, where this side of the triangle represents the length of the shadow. That's the actual length of the shadow divided by 2. And this side represents the height of the stick. Again, that's the actual height divided by 2. So now, what I have is the representation of angle alpha that we were looking at on the diagrams. The next thing that I need to do, this represents a chord of the circumference of the earth, and I need to mark that on a circle, any circle. I could do that on a piece of paper. I could do it in the dirt if I needed to. This doesn't have to be a piece of paper. It could be 3 sticks. You could do it. You could do this 1,000 ways. The process is very simple. I take the vertex of this angle alpha, I put it right at the center point of that circle, and then I mark the angle. Boom, boom. That's these 2 lines. Perfect match for what we measured. So we're done with that. Now what we've got to know is what percentage of the entire circumference is this chord length here. The way we do that is with a pair of dividers. Now these things date back to the Egyptians. The Greeks certainly would have had them too. I know that the latitude here is roughly 36 degrees. In other words, this is going to be about 10% of the total circle. So I decided just to arbitrarily try this, setting the dividers at those points. And then I stepped it off all the way around the circle, like so. And you can see all the dots I made all the way around. And when I came back to this end, ended up right there. There's that last dot. It's very, very close. So for all intent, we can say that this is 10% of the circumference of the Earth. And I know that this distance is 2,466 miles. That's from here to the equator, times 10, 24,660 miles. I'd say that's pretty good for a guy with nothing more than a stick, a pair of dividers, a couple of pieces of paper. Okay, Antonio. That little trick I just showed you, by the way, does not have to be 10 segments or 50 segments or 60 segments. It could be any number that works out best. It could be 41, 20, it could be any number. So I think that's about all we need to say on this one. I believe what we've been able to prove to you is that when you multiply two wrong numbers together, you're very likely to get a wrong number. So guys, hope you enjoyed it. Don't forget to smash that like and subscribe button, and we'll see you on the next one.